This was a short quiz featuring some of the applications or real-world problems involving exponential functions. Let's see what we did. Okay. The first thing you always have to do for these problems is decide which one of the formulas you're going to be using. These two formulas are for compound interest. This one is the one that we use when you're compounding semi-annually, quarterly, monthly, daily, that type of thing. And the n value is how many times a year you're compounding. So semi-annually would be twice, quarterly would be 4 times a year, monthly would be 12, daily would be 365. This is the formula that we use for compound interest, but when you are compounding continuously. And these two formulas are the ones we use for general growth with the plus or general decay with the minus. So that's our first task. You deposit $9,000 in an account that earns 4.3% annual interest. Find the balance after 8 years if the interest is compounded with a given frequency. Okay, so this is a compound interest problem, so we're dealing with one of these two. Or both. First, we're supposed to do quarterly. That's going to be this formula. So here we go. $9,000 is the initial amount that you deposit. So that's going to be your principal, so we'll put that in for P. So we've got Y equals 9,000 times 1 plus. R is the rate as a decimal, which would be 0.043. So 0.043 for quarterly, N is 4. And then N times T, so that's 4 times 8 years. So that is the setup. We can just put that in our calculator. So we get $12,671.92. Okay, so that's how much we would have 8 years later if we deposited $9,000 now. Continuously, we use the PERT formula for that. So that's going to be Y equals 9,000 is the P. E is just E. It's a constant, approximately 2.72. The rate we saw was 0.043. Times the time, 8 years. So we will put this in our calculator. I'd have to move this over. To get to the E, we'll do second, this guy. Okay, so that's $12,695.21. So that's it for number 1. So as you can see, if you compound continuously, you get a little bit more money than you do if you compound quarterly. Not a lot, but every dollar counts in my book. So number 2, if you need $15,000 in 10 years, how much should you invest now at 6.5% annual interest compounded continuously? Excuse me. Compounded continuously, once again, we know that that is going to be the PERT formula for compounding continuously. Now, the thing you must be careful about, it says if you need $15,000 in 10 years. This $15,000 is not the initial amount. That's the eventual amount that we want 10 years from now. So instead of putting this in for P, the principal, this amount is going to be the Y value, the eventual total. So it needs to go out front. So this equation, thinking of the PERT formula, is going to start with your 15,000. That is the Y value. The question is, how much should you invest now? You're being asked what is the principal that you would have to invest. So we'll just leave P as P. So here comes the PERT formula. PE, the R is the rate, which of course is 0.065, times time, 10 years. So here we go. We need to solve this for P. So what you're going to do is just divide both sides by this part to get P by itself. So with that in mind, this cancels out, leaving P. So we can just put this in our calculator. Hey, wasn't supposed to happen. Okay, that's a fail. So there you go. So we would need $7,830.69. So that's it for number 2. Now number 3. There are currently 2,435 students at Roswell High School. Over the next 4 years, the number of students is expected to decrease by 8% each year due to redistricting. Write a model that gives the number of students Y after T years from the present. So we're supposed to write a model. Writing a model means writing an equation. A lot of students sort of mess this up. First of all, let's decide which one of these equations we're dealing with. Well, these are students, so we're not talking about compound interest, which means we're dealing with general growth or decay. Since we are talking about the number of students being expected to decrease, this is going to be the decay model, so we will be careful to use the minus version of this. So our model will be Y equals, our initial amount is 2,435 students. We will do 1 minus the rate. I'm looking at 8%, which translates into 0.08. Okay, It's not a very good decimal. I think I can do better. Now, T years. This is very important. Many students mess this up. For some reason, students want to put a number here sometimes. Sometimes they'll put in the 10, or I'm sorry, they'll put in the 4 because it says 4 years. But no, the model, you're going to have a y and an x or a t. So this is the model, just like this. The one thing you might do, instead of leaving it as 1 minus 0.08, you might want to go ahead and write the answer for that. 0.92. So I actually prefer this. It's just more compact, it's more professional, but I would accept either. But you have to have the t. If you put in a number here or you leave the t off, it's wrong. Now, use the model to estimate the number of students in the year 2018. So it says currently. Currently means the year 2014. So we're talking about 2014 to 2018. Obviously that's 4 years. The fact that this says next 4 years, that's irrelevant. They're just letting us know how long this pattern took place. If this said 10 years, I would still be using 4 because 2014 to 2018 is 4 years. So I'm about to put in 4 for t, but not because it said the next 4 years. That's irrelevant. The only reason why I'm using 4 is because 2014 to 2018 is 4 years. So anyway, if I put in 4 for t, that's how you do it. If we put this in our calculator, that should be it. So let's round to the nearest student since you can't have a partial student. So we're looking at 1,744 students. And that was it for this little quiz.